Hello, my name is Stacy Oliveira, and I am recording the question number 13 through 16 for group project hours spent studying. Question 13, it says use the empirical rule or Chebyshev theorem to provide a prediction of the spread of the data set that is within 3 standard deviations away from the mean. Provide the interval, percentage, and proper sentence in your calculations. Since our distribution is skewed, we will be using the Chebychev theorem. Here is the Chebyshev theorem equation or formula. So at least 1 minus 1 over k squared times 100%. So here we can see that our k is equal to 3. So when you put that into the equation, 1 minus 1 over 3 squared times 100% is equal to 88.8888%, but when rounded, it's at 88.89. So according to Chebychev's theorem, there are approximately at least 88.89% of hours spent studying within 3 standard deviations within the mean, with an interval of 0, to 28.42 hours. In question 14, it says create one confidence interval for the mean, proportion, variance, or standard deviation. Use 90, 95, or 99 levels of confidence. Provide the critical value, a sketch of the critical value, the standard error, and all formulas and calculations. Clearly state the parameter you are estimating. Use technology for the sketch to confirm your final answer. We decided to go with 95% confidence interval for the population mean. Here are our formulas that we have been using. And then our critical value, our values provided is the sample standard deviation of 6.166. And then we have our sample size of 60. And then our degree of freedom, which is our sample size minus 1, which is 59. And then our sample mean, which is 9.867. Our confidence interval, which is 9.95, our A, which is 0.5, and A over 2, which is 0.025. Here in the calculations, you can see that we ran the code for the t interval, which is 0.025, 59, which gave us our critical value of negative 2.0009. 95317. Then we here rounded to 2.001. For the standard error, we did our critical value A over 2 times the sample standard deviation over the sample size squared. And then we just added everything in, so 2.001 times 6.166 over the square root of 60, which equal to 1.59285, when rounded 1.5929. And then for the interval, as you can see, here's the equation. Our mean, our sample mean, minus our error is less than the mean, which is less than the sample mean plus our error, our standard error, which is 9.867 minus 1.929, less than the mean, which is less than 9.867 plus 1.5929, and then this is our answer. So the 95% constant interval for the mean is 8.2741 and 11.4599 hours spent studying, which is the min and max. For question 15, it says take a look at your data set and find out how many data values are needed to create an 80% confidence interval for the mean. Assume that you want the error to be E equals 0.10 units from the population mean. Provide all formulas, calculations, and appropriate sentences. Our values provided is our sample standard deviation of 6.166, our sample size of 60, and then our sample mean of 9.867, and our error of 0.10. Our critical value, because the standard deviation is not given, we will use the t-interval, which is here. The critical value, C equals 0.80, A 0.20, and A divided by 2, or over 2, equals 0.10, degrees of freedom of 59. Here you can see that we ran the code again, t-interval, but this time with 0.10 and 59, which gave us negative 1.296065725, which gave us, when rounded, 1.2961. Our sample mean interval, here is the formula, and then when we put everything in, it's 1.2961 times 6.166 over 0.10, then is greater than 6.6386.811, which is then rounded to 6387. So we need at least 6,387 more study times to create a confidence interval of 80%. Then, question 16, design a hypothesis test for the mean, proportion, variance, or standard deviation. Provide a sketch of your solution. Your sketch should include critical values, tests, statistics, and p-values. Use technology for the sketch. Provide all formulas and calculations. Use technology to justify the p-value found. You may use a method covered in class. Include a proper wording in the conclusion. So for our hypothesis test, assuming that the population mean is greater than 8 using a 0.5 significance interval, our claim is that the mean is greater than 8. So when we state HO, HO is first equal to 8, and then H of A or H1 is the mean greater than 8. The test statistics, the sample values, we have our sample standard deviation of 6.166, our sample size of 60, our standard mean of 9.867, and our significant interval of 0.05. And then stated here is our formula for the test statistics, which is our mean, excuse me, our sample mean, and then our mean over our sample standard deviation divided by the square root of our sample size, and then after putting everything in, 9.867 minus 8 over 6.166 divided by the square root of 60 equals to 2.3454, and then we are doing the p-value. So for the p-value, p is equal to 0.0112, and this is how we got it. We ran the test, the t-test. And then our conclusion is that we reject HO with our significance interval of 0.05, our confidence of 0.95 because the p-value of 0.112 is less than 0.05, which is our significance level. And that is it.